Today we have a heated lunchbox. I made it a few years ago. You can put there a plastic lunch container and it doesn't melt because the heating is controlled. The device connects to the car's 12-volt socket or a portable power source with a 12-volt output. Let's look inside the device. The inside is surrounded by EVA foam from a sleeping mat. It has a thermometer, an LED that blinks when the temperature is reached, and a relay that turns off the heating if the temperature goes over 80 degrees. The heating element is 50 watts and heats the aluminum tray. The device works, but the temperature can vary a lot. I want more accuracy and an automatic shutdown. This can be done by adding a microcontroller. A MOSFET relay replaces the mechanical relay. The NTC sensor measures the temperature and we need a 10K resistor and a piece of circuit board. I'm using the DigiSpark attiny85 module. To measure temperature, we need a voltage divider. The microcontroller reads the voltage of the divider. The chip turns the MOSFET relay on and off based on the value. I can't use hot glue because the device gets very hot and I'm using this double-sided tape instead. Now let's start the wiring. The DigiSpark attiny can be connected directly to 12 volts because it has a 5-volt regulator. We also connect the 12-volt power to the MOSFET relay. Now we build the voltage divider for temperature measurement. We can take ground from the MOSFET. The yellow wires go to the NTC resistor. The green wire controls the MOSFET relay. It turns off the heating when temperature goes over the limit and turns back on when it cools down. The red wires go to the 50-watt heating element. The NTC resistor is in contact with the aluminum tray. The wiring is done and now we can upload the program. The DigiSpark attiny is programmed with Arduino software. Here's the simple code I uploaded to the chip. I also added a LED to pin 3 that is pulsating when the device heats up. It's just blinking when the relay cuts off the heating and turns off when the automatic power shutdown happens at the end. Finally, let's test the device. A bit of water is needed to heat transfer. Also, it keeps the surface temperature lower to protect the plastic. The device starts heating and the LED is pulsating. After 60 minutes, the relay cuts off and the LED starts blinking. The upper thermometer shows a higher reading because its sensor is inside. The heating completely stops 18 minutes after the first cutoff, or 80 minutes after the heating started. The device works as expected. I hope you enjoyed the video. Thanks for watching.